Students, we will discuss questions from metallurgy which are very important and which are expected from this particular metallurgy. So, let us see question number 1. The lightest metal is the lightest metal: A. Lithium, B. Magnesium, C. Calcium, D. Sodium. See, lithium, magnesium, calcium, sodium are given. You will be knowing this particular atomic weights of this. See, lithium atomic weight is 7, magnesium is 24, calcium is 40, sodium is what, 23. You can easily understand from this. So, up to at least 20 elements, their atomic number, their mass numbers should remember. Among these, lithium is what, only 7 atomic mass. Therefore, lithium is the lightest metal. So, for the question number 1, answer is A. Question number 2, a mineral is called an ore if. See, a metal is having different types of minerals. Take X metal is having different types of minerals. A, B, C, D, like this, different types of minerals are there. But only from B or C or A or D, we extract the metal. We will choose such a mineral that from which we can extract the metal less expensively, profitably. Less expensively or profitably. So, let us see the answers now. A mineral is called an ore if a metal present in the mineral is costly. A metal can be extracted from it. A metal can be extracted profitably. A metal cannot be extracted from it. What I said. A metal is having different types of minerals, but we take among those only one at the ore, from which we can extract the metal profitably. So, question number 2, see, a metal can be extracted profitably. So, for question number 2, answer is C. Question number 3, sapphire is a mineral of zinc, copper, Hg and aluminum. Zinc, copper, mercury and aluminum. See, aluminum is actually important. Ore of aluminum is bauxite. We agree. This is actually Al2O3. Whenever Al2O3 is actually carrying some impurities like titanium and iron, this is carrying some impurities like either you take titanium or iron impurities. Whenever Al2O3 contaminated with some impurities like titanium and iron, that is getting some blue color. So, sapphire is nothing but a blue, sapphire blue we call. So, it is only the ore of aluminum or mineral of aluminum. Therefore, question number 3, answer is D. Question number 4, sperrylite is A. AgCl, B. PT, AS2, Fe2O3, D. SnO2. So, you might be knowing this particular AgCl, this is actually horn silver. PtAs2, let us see. Fe2O3, it is hematite. SnO2, you might be knowing this. This is tin stone. This is horn silver, hematite. This is what tin stone. The remaining, this particular PtAs2 is sperrylite. Therefore, question number 4, answer is B. Question number 5, Calamine is an ore of. Calamine is an ore of. See, mercury, zinc, cadmium, calcium. Calamine, you might be remembering, this is one of the carbonate ore of zinc. Zinc carbonate known as calamine. So, question number 5, answer is B. Question number 6, cinnabar is an ore of. Cinnabar, CaCuS, Cus, Ag2S, Ag2S, ZnS, HgS. Cinnabar. See, Cus is actually known as copper glance. Ag2S is argentite. This is zinc blend. This is cinnabar. Cinnabar is an ore of mercury and HgS is known as what? Cinnabar. See, question number 6, answer is D. Question number 7, which is not an iron ore. A hematite. Hematite is actually Fe2O3. Limonite. Limonite is again Fe2O3, 2H2O. Cassiterite, the ore of tin stone we call, otherwise cassiterite. D. Magnetite. 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 Fe3O4. Here the question you see, which is not an iron ore. See, this is what? Hematite. This is limonite. This is tin stone or cassiterite. This is magnetite. In all these, iron is there, but tin stone or cassiterite is the tin ore. Therefore, question number 7, which is not an iron ore. Question number 7, answer is C. Question number 8, which contains both calcium and magnesium. Limestone, see calcium carbonate. Dolomite, CaCO3, MgCO3. Chalk, chalk is simply again calcium carbonate only. Feldspar, you can take potassium feldspar, KAl, Si3, weight, in which both calcium and magnesium are there. See, dolomite, calcium and magnesium are there. Therefore, question number 8, answer is B. Question number 9, diaspores. See, first one is given as Al2O3, single water molecule, Al2O3, 2H2O, and next simply Al2O3, Dal2O3, 3H2O. So, diaspora is actually carrying, it is Al2O3 but carrying only one water molecule. So, question number 9, answer is A. Question number 10, Kieserite is ore of copper, aluminium, magnesium and iron. Kieserite is actually magnesium sulphate single water molecule. This is what we call Kieserite. So, question number 10, Kieserite is an ore of magnesium. Therefore, answer is C. Question number 11, calcium occurs in nature as limestone. Generally, calcium available in the nature as calcium carbonate formula. Calcium carbonate form. Limestone is what calcium carbonate? Marble. Marble is actually white stone, you might be knowing. That is also carrying major component calcium carbonate only. Coming to dolomite, calcium carbonate, magnesium carbonate, both are there, and all of this. So, in this particular limestone or marble, dolomite, all are carrying what? Calcium carbonate only. Therefore, question number 11, answer is all, answer is D. Question number 12, Wolframite ore contains zinc, tungsten, hafnium, aram. For this type of questions, you should remember compulsory almost all the ores. Wolframite. Wolframite is actually FeWO4. This is actually wolframite. Wolframite is actually carrying tungsten. It is actually tungsten ore. So, question number 12, answer is B. Question number 13, oil used as frother in froth flotation processes. See, in froth flotation, we have to use an oil which is actually frother, which gives froth. A, pine oil, B, mustard oil, C, coconut oil, olive oil. One is pine oil. This is what? Mustard oil, coconut oil, olive oil. Among these, you have to choose which is actually a good frother, like soap. This is actually pine oil, it only gives a large amount of frothing. Therefore, the oil which is actually giving more froth, such oil is actually generally used for froth flotation process. Therefore, question number 13, answer is A. See, question number 14, the ore concentrated by electromagnetic separation. The ore separated by electromagnetic separation. A, wolframite. The wolframite is actually FeWO4, hematite, cassiterite, all of this. The ore concentrated by electromagnetic separation is. See, this particular wolframite, FeWO4, this is often carrying, this is what? Magnetic. This is carrying some gango impurity, non-magnetic impurity will be there. For separation of non-magnetic impurity from magnetic ore, we apply this particular electromagnetic separation. Coming to hematite, yes, iron ore, this is magnetic, and some non-magnetic impurity can be removed by magnetic separation. SnO2 carries often some magnetic gango. In this gango will be magnetic substances. Magnetic. Wolframite is carrying out some non-magnetic gango, and hematite is carrying some non-magnetic gango, and SnO2 is carrying some magnetic gango. Whenever a ore and gangu. Ore plus gangu, impurity. Gangu means impurity. One is magnetic, the other is non-magnetic. In such case, we apply electromagnetic separation. So the magnetic part, magnetic substance separated from the non-magnetic substance. Therefore, in all these cases, one is magnetic, the other one is non-magnetic. Therefore, for all, question number 14, all are the answers. Therefore, wolframite, hematite and cassiterite all can be separated or concentrated by electromagnetic separation. Therefore, question number 14, answer is D. Question number 15, leaching process is used to get AG, AU, AG, AU. See both. D, none. 15th, leaching process is a chemical method of concentration of the ore. Chemical method of concentration of the ore. Chemical method of concentration of the ore. This particular AG and AU, these are generally carrying some impurities like, take AU, AG. Let me say AG, it is carrying some impurities XYZ, these are impurities. This particular AG is actually leached with sodium cyanide, 8 NaCN, presence of atmospheric oxygen, some amount of water. AG only converts into a soluble complex 4 Na Ag Cn taken twice. Like this, you are getting a soluble complex of silver. Whatever the impurities are there, the impurities will be completely removed because these are not reacting with water, sodium cyanide. Silver and Au both are soluble in sodium cyanide. Therefore, leaching is one of the chemical method to concentrate the ore or separate the metal. So, Ag and Au both are actually soluble in sodium cyanide. Both can be removed or separated or concentrated from their ores. Therefore, question number 15, answer is C. Question number 16, roasting is used in the extraction of A. galena, PBS, iron pyrites, copper glands, iron pyrites is FeS2, copper gland says Cu2S. D is what? All. Roasting is used generally for sulphide ore heated in the open air in the presence of oxygen converted into what? Oxide. See, these are all the three are actually sulphide ores, galena, iron pyrites and copper glands. All can be subjected to roasting process so that they are all converted into what? Oxides. Therefore, question number 16, answer is D. Question number 17, calcination and roasting are different names of the same operation used for the purification of metals, usually carried out in a reverberatory furnace, employed for the concentration of the ore. This calcination and roasting are generally, after the concentration of the ore, we apply this particular calcination and roasting. The calcination and roasting generally carried out in a reverberatory furnace. Both of these processes. Therefore, calcination and roasting are different names of the same operation. These are actually two different operations, not same operations, different operation. Used for the purification of metals, not the simply purification of metal. These are actually one of the method to convert the metal into metal oxide, not the purification methods. Usually carried out in a reverberatory furnace. Yes, these two are generally carried out in a reverberatory furnace. D. Employed for the concentration of the ore. These are not the concentrated concentration methods. These are after concentration we are applying. So, 17th question, answer is only C. These two processes generally we can carry out in a reverberatory furnace. Therefore, question number 17, answer is C. Question number 18. Which of the following process involves the roasting process? A. Zinc carbonate. B. Fe2O3. C. PBS. D. Al2O3. H2O. See, roasting process generally applied for the sulphide ores. This is the carbonate ore. This is on strong heating. It is decomposed to produce zinc oxide and CO2. This is not the roasting process. Generally, it comes under calcination. Coming to Fe2O3, treated with what? Coke or coal. Then this is reduced to produce 2Fe plus 3CO. This is simply what? Reduction. This is simply reduction of Fe2O3 with using carbonate comes under reduction. This particular 2 PBS with 3O2, then you are getting 2 PBO plus 2 SO2. See, sulphide ore, oxidation, roasting, you are getting what? PBO. This particular Al2O3, 2H2O, this is simply heated. This you are getting what? It is dehydrated. Simply we can call it as dehydration process. So, wherever the sulphide ore is there, for that only we apply this roasting process. So, therefore, question number 18, answer is C. Question number 19, which is not a basic flux. What is actually flux? A foreign substance which is added to remove the gangue material, either it may be acidic or basic. Flux are of two types, acidic flux and basic flux. Question is there, which is the basic flux? See, it is calcium carbonate, B. calcium oxide, C. SiO2, D. MgO. Which of the following is a basic flux? Which of the following is not basic flux? See, among this calcium carbonate, basic, this is also basic. Because calcium and magnesium are belong to alkali earth metals, their compounds also basic in nature. But silicon dioxide, this is acidic, which is not a basic flux. Therefore, silica is actually acidic in nature. Therefore, question number 19, answer is C. Question number 20. Thomas slag is calcium silicate, calcium phosphate, tricalcium phosphate and calcium silicate, calcium ammonium phosphate. Thomas slag is actually, it is mixture of calcium phosphate plus calcium silicate. This is actually Thomas slag. In the manufacture of iron, you are getting this particular as the one of the byproduct. This is used as actually a fertilizer. So, Thomas slag is calcium phosphate and calcium sulphate mixture. There question number 20, answer is C. Question number 21. In India, thorium deposits are found mainly in the form of A. lignite, B. rutile, C. monazite, D. none of these. Mainly monazite is actually a ore of lanthanides and actinides. This particular monazite is carrying some lanthanides and also actinides. Therefore, thorium is mainly there in a monazite ore. Therefore, question number 21, it is answer is C. Question number 22. Which radioactive element is more abundant in India? This you have to remember, it is actually a general question in chemistry. A is thorium, B is uranium, C radium, D radon. More abundant radioactive element in India. This is what thorium is actually more abundant. Therefore, question number 22, answer is A. Question number 23. Carbon reduction is used for the extraction of A is iron, B is potassium, C is aluminium, D is given as all. D is given as actually none. See, carbon reduction, potassium and aluminum are actually strong reducing agents. The reduction of these and their compounds is not possible by carbon. Generally, iron is actually extracted by using reduction by carbon, Fe2O3 plus, take hematite ore, 3C, strong heating, you are getting 3CO plus 2Fe. This is the method. Carbon reduction method only generally applied for this iron, but not potassium and aluminum. Therefore, question number 23, answer is A. Question number 24, which metal cannot be extracted by carbon reduction process? See, one is lead, aluminium, mercury, zinc. See, carbon reduction method is generally not applied for either first A group elements, second A group elements and aluminium, because these are actually strong reducing agents. The metals and the metal compounds of this particular first A group, second A group and aluminium cannot be reduced by carbon. Therefore, lead, mercury, zinc can be extracted by carbon reduction method, but aluminium cannot be extracted by carbon reduction method. So, here question number 24, answer is B. Question number 25, tin is extracted from tin stone by heating it in a furnace with A is calcium carbonate, B is calcium oxide, C is steam, D is what? Coal. Generally, tin is extracted from tin stone or cassiterite. This is what? SnO2. SnO2 treated with what? Coke or coal. Then this is Sn plus to consider 2C, then you are getting what? 2CO. In this way, tin can be extracted. Therefore, question number 25, answer is D. Question number 26. After partial roasting, the sulphide of copper is reduced by A. cyanide process, B. electrolysis, C. reduction with carbon, D. self reduction. Self reduction method. Generally, take Cu2s, 2Cu2s, this self reduction, 3O2, then you are getting 2 Cu2O plus 2SO2. After this, the same Cu2O, 2Cu2O, again Cu2S. So, part of the ore is converted into oxide. This oxide is completely reduced to copper metal by self reduction. See, again CuS reducing the cuprous oxide. Then you are getting here 6Cu and SO2 like this. This is what partial reduction. This particular CuS is actually converted into what? Cuprous oxide. Cuprous oxide again reduced to produce what? Copper metal. Therefore, after partial reduction, partial roasting. After partial roasting, then remaining copper ore or cuprous sulphide completely reduced to copper metal. This is only self reduction, means we are taking this as cuprous sulphide in a vessel and openly we are heating in the open air. Then this particular part of the sulphide is converted into oxide. This particular oxide is reducing entire cuprous sulphide to copper. Part of it is converted into cuprous oxide. This cuprous oxide is reducing entire cuprous sulphide to copper. We are not adding anything to that, just we are heating open air in the open vessel. This is what self reduction. So, it itself is reduced to copper metal. Therefore, we call it what? Self reduction. Therefore, 26th answer is D. Question number 27. From gold amalgam, gold may be recovered by A. Addition of zinc to metal, B. Electrolytic refining, C. Distillation, dissolving Hg in HNO3. See, generally gold amalgam is there. Gold amalgam AuHg. This generally actually distilled on strong heating. The mercury which is actually more volatile, it is vaporized. So, by distillation process only we can get gold from the gold amalgam. Therefore, question number 27 answer is C. Question number 28. The formation of Al2O3, large amounts of heat is evolved. This property is used in deoxidation, confectionery, indoor photography, thermite welding. See, in thermite welding, see, suppose Fe2O3 is there. In thermite welding, we apply aluminum as a reducing agent. Look here, Al, we are heating to higher temperature. Then this particular iron, then you are getting Al2O3. Large amount of heat is generated. Large amount of heat is generated. This particular is actually liberating large amount of heat. Therefore, in the formation of Al2O3, large amount of heat is evolved. This property is used in thermite welding. This is what you call thermite welding. This particular reduction of a metal oxide by aluminium is generally known as thermite process or thermite welding. Why we call it thermite welding? Whatever the metal produce, that will in the liquid state. This particular liquid metal you can use for the welding of this particular iron beams or railway track. Therefore, this particular metal produce used for welding. Therefore, it is known as what? Thermite welding. So, answer is D. Question number 29. The phenomenon of removing layers of basic oxides from the metal before electroplating is called. What we call that particular process? A. Galvanizing, B. Anodizing, C. Pickling, D. Pulling. See, galvanizing is what? Galvanizing, you take galvanizing. So, making a coating of layer of zinc on the surface of iron, we call it what? Galvanizing. B. Anodizing, making this particular anode a thin layer of oxide over it. that we call it as what? Anodizing. C. Pickling. Pickling. Pickling is the process. In the ore there actually some basic oxide layers are there. This is actually washed with sulfuric acid. Then sulfuric acid, strong acid, remove this particular basic oxide layers. Basic oxide layers. This particular process is what we call pickling process. The process in which basic oxide layers from a ore, basic oxide layers from a ore removed by washing with sulfuric acid, known as pickling process. Next, D. Polling. D is what actually polling. Polling is nothing but green poles of wood is used for stirring the molten mixture. That what we call polling. Therefore, here the phenomenon of removing the layers of basic oxide from the metals before electroplating is removal of basic oxide layers by using sulfuric acid, known as what? Pickling process. Therefore, question number 29, answer is C. Question number 30. Before introducing FeO in blast furnace, it is converted to Fe2O3 by roasting, so that FeO is actually converted to Fe2O3. What is the reason? It may not be removed as slag with silica. It may not evaporate in furnace. Presence of it may increase the melting point of the charge. None of this. See, once FeO is there in the furnace, FeO can easily form ferrous silicate slag. See, FeO can easily interact with SiO2, silica, and forming what? Ferrous silicate slag. But it should not be easily convertible into slag. Therefore, once you are adding FeO, it is made to convert into what? Fe2O3. Fe2O3. So that Fe2O3 cannot freely interact with silica, cannot be converted into ferrous silicate slag. Therefore, once you are adding FeO, it is made to convert into Fe2O3. Therefore, question number 30, what is given? It may not be removed as slag with silica. Therefore, question number 30, answer is A.